Now we'll look at transformations of quadratic functions. So the standard form of a quadratic function is f of x equals a times x minus h quantity squared plus k, where our vertex is at hk. Now, wanted to kind of bring that back into the thought process here. Now, consider our basic function f of x equals x squared. We're going to talk about how this gets moved around. And given different values, this format is going to shift it around. So f of x equals a times x minus h squared plus k is the same graph, but it might be shifted. It might be shifted vertically, horizontally, and it could be stretched or compressed. It could even be flipped if you had a negative leading coefficient. But we're following all the same rules about transformations of functions here. So shifting up and down by changing the value of k. If f of x equals x squared, it can be shifted up or down by adding k to the function. So f of x equals x squared plus k. If k is positive, it goes up that many units. If it's negative, it goes down that many units. So our example, determine the equation for the graph of f of x equals x squared that has been shifted up 4 units. Also determine the equation for the graph of f of x equals x squared that's been shifted down 4 units. So what we're looking at then is, for going up 4 units, f of x equals x squared plus 4 shifts it up 4 units. And f of x equals x squared minus 4 will shift it down 4 units. Now the next thing we'll look at here is the horizontal. Shift left and right by changing the value of h. That's this value here. F of x equals x squared can be shifted left or right by adding h to the variable before squaring. So if we have this set up here, f of x equals x minus h squared, notice the minus there. If h is greater than 0, the graph shifts right h units. If x is less than 0, meaning negative, the graph is shifted left h units. Just to be clear here, if you're subtracting the negative, that'd look like x plus the value. So example 6 says, determine the equation for the graph of f of x equals x squared. What a space there. That has been shifted right 2 units, and then determine the equation for shifted left 2 units. So f of x equals x minus 2 squared shifts right 2 units, and f of x equals x minus negative 2 squared, which is x plus 2 squared, shifts left 2 units. Our last concept here is stretching or compressing by changing the value of a. So f of x equals x squared, g of x equals ax squared will stretch or compress the function of f of x. So that where if the absolute value of a is greater than 1, f of x will be stretched by a factor of a. If the absolute value of f of x, I should say, I guess, I'm just going to say leave it like that, is less than 1, and then it's going to be compressed by a factor of a. I was going to say it's greater than 0, but it's kind of trivial if it is equal to 0. Determine the equation for the graph of f of x if f of x equals x squared that has been compressed vertically by a factor of 1/2. So that'd be f of x equals 1/2 x squared compresses by a factor of 1/2. I'm sure someone's going to argue there. There's a logical statement that someone can make an argument that I wasn't logically consistent, but I'm just going to keep with that. Also determine the equation for the graph of f of x equals x squared that has been vertically stretched by a factor of 3, excuse me. So that'd be f of x equals 3 times x squared. Well, vertically stretch by a factor of 3. Okay. The last concept, and we don't really have any examples for this, but just to kind of hit on it, the axis of symmetry is this mirror line that reflects the both halves of the parabola. So if you have a parabola like so, right down the middle is your axis of symmetry. Now, a couple things. I want to tie some concepts together. If you have it in this form here, ax squared plus bx plus c, that axis of symmetry will be located at negative b over 2a. That's also the location of h, so that h equals negative b over 2a. And then, so if you were trying to find your k, f of h is going to be f of, oh, this should be, I'm sorry. So k is basically f of h, which is f of negative b over 2a. And that would give you your hk, which would also give you your f of x being, wouldn't give you the a there, but it'd give you x minus h squared plus k. So you can use that in that process. Okay, that's it for this video in this section.